Now a science unit report on how new technology is changing how airplanes are built. Lee Hochberg of Oregon Public Television visited Boeing in Seattle.
There's no bigger celebration at an aerospace factory than the rollout of a new airplane, like Boeing's 777 a decade ago.
Ladies and gentlemen, this is the future of flight.
So it was last month with Boeing's latest jet, the 787 Dreamliner, except there was no airplane. It was a virtual rollout, symbolic of the virtual way the 787 is being built. Boeing designers and engineers have created the jetliner on computer screens, and they say they've worked the bugs out there. Enough so, says process engineer Simon Cook, that they don't need actual wings and wheels.
They're not actually physically producing parts, and that's the important thing about this software, is we're doing it all prior to doing physical parts. We're building it before we build it.
Boeing has used animation to design planes before, but expensive problems cropped up in the assembly process anyway.
It wasn't until we practically had one of these in the factory and we were putting them together that you would actually say, hey, we've got a clash between this part won't fit, or the mechanic can't get in there to actually fit this part. It would be then that we would find this problem. When the parts are here, it's too late. We've got massive rework. It slows down the production rate. It has a dramatic effect on when we can provide our customers the planes.
But 787 chief engineer Tom Kogan says the latest generation of animation software has changed all of that.
You think about how we used to do it, and it just feels archaic.
Kogan says 3D models produced by France's Dassault Systems enabled his engineers to see if parts will fit in the 787, or if workers can squeeze in to install them, before those parts are even built. They found, for example, that a planned cargo door wouldn't be able to be installed properly, and that a rack for electronics wouldn't fit.
So you can see they've tipped the rack over, and they're moving it out of position, and there it is hitting structure.
Hitting those
the top
beams.
Those top beams, right. It could have been very expensive because not only do you have to redesign the rack, but maybe you have to redesign some structure around it or redesign the tool, and it can get very expensive. You can lose days, maybe a week of time to go fix something like this, and we just don't have that kind of time.
Software manufacturer Dassault says such 3D simulation is the way of the future, and not only for airplanes. CEO Bernard Charlet.
You think about any physical products you touch every day, whether it's a phone, a car, a coffee machine, no matter what it is, the world of manufacturing now is becoming virtualized. It's really a revolution. It's really a big new playing field for the way the world can work on imaging.
This is where it all comes together, and it's not going to be like anything we've done before.
The excitement over the 787 goes beyond Boeing's flight hangar. 37 customers already have placed orders for 461 new planes, for a plane that won't even be completed until mid-2008. It's a big change for a company that had been struggling in its competition with Airbus. Airbus has now launched its A350 XWB to compete against the 787. But in an interview with the French newspaper Le Monde this fall, former Airbus chief executive Christian Striff said it will take us about 10 years to catch up with Boeing in terms of development and efficiency.
People look at the 787 and think just another airplane. It is not.
Aviation analyst Michael Boyd of Colorado says virtual design is only one of several technological advancements that make the 787 a history-making plane.
It is every bit as much of a breakthrough as the first 707 was when it was announced in 1955. It is going to change air transportation, all for the better.
Boyd points to new, lighter and stronger composite materials, which will be used on half of the 787's fuselage and wing. Though some critics say those composites, made from carbon and graphite, are more prone to dents and damage, Boeing says they don't corrode and are slower to fatigue than the aluminum used in current planes. Airlines' maintenance costs on the 787 could drop, and passenger ticket prices could drop with them. And Boeing says the composites will make the 787 more comfortable to fly than previous jets. The stronger fuselage allows the plane to include larger windows, which are generally a weaker part of a plane. And cabins will be able to be pressurized at a higher, more comfortable air pressure.
So at the end of the flight, the passenger will get off the airplane feeling better.
Still, for all of the fanfare, there are nagging concerns about the 787. Early estimates have it coming in 5,000 pounds overweight.
Is this thing a light, fast airplane, or when they get it off the line, does it weigh 30 tons more than it's supposed to? If they can bring it in close to what they're planning, yeah, they're going to have a winner. If it's significantly heavier, that's going to change the equation a great deal.
The seat tracks are what hold the seats to the floor and to the airplane. We have a better design that will take several hundred pounds out.
Boeing's 787 general manager, Michael Baer, says there are several places where the airplane can be made lighter. But critics also wonder about the revolutionary change in where the 787 is going to be built. Boeing has partnered with entities worldwide to design and build entire sections of the 787, which will then be flown to Seattle for final assembly. Analysts say it could leave the 787 subject to the vagaries of international politics.
What happens if that company that you go in the bid for say, let's just say an elevator section, has a revolution at that country, or the company goes out of business? You could have a glitch in the supply chain very easily with that. And again, I'm sure Boeing is looking at it, but when you have multiple suppliers from multiple places across the globe, it gives you a lot of leverage in terms of bidding it out. It also gives you a lot of risk if something goes wrong.
Boeing says that's just the modern reality of doing business.
Is there additional risk? Sure there is. But with that risk, there's reward. And we think that that's a great trade. You know, the world is global. And for us to think that, you know, all the best ideas were here in the United States, it's a little short-sighted. It's not true. We've proven it to ourselves, certainly on this program, where we look at what each of our partners have brought to the table to help us build this airplane, and they've each brought something unique that we could not have found anywhere else. So in the end, we have a stronger team, and we're going to end up with a better product.
With airlines facing aging fleets, industry forecasts say that in the next 20 years, nearly 20,000 new airplanes will be needed.